All right, so this is Intro to Computer Vision, and we're going to learn how to build your own object detector and data sets for that. My name is Sage Elliott, and I work at a company called Plainsight. Again, like I mentioned, we are formerly 6Skill, so a couple of the links still might say 6Skill in there. Hit record because I usually forget, but I actually hit it. All right, so setup. So I think I mentioned this, we'll be using an online data science coding environment called Google Collab. So you really just need a Google account, a modern web browser. And then to do the data annotation side of things, you can just sign up here for free. And it's also an online tool. So you don't need to download or install anything. What this workshop is, so it's hopefully a very friendly introduction to computer vision, kind of designed with no previous experience expected, but knowing some Python will probably be helpful when we get to the coding part. But even if you're new to programming, stick with it. I'm going to be explaining what's happening the best I can. And if you ever want to, we can go back and review something. And I'll also be sticking around at the end. So feel free to ask questions as we go in the chat. I'm not going to maybe see everything depending on how noisy it is in there, but I try to answer all the questions I can. If I miss it, feel free to ask it again. And then again, I'll be hanging out afterwards if you want to repeat it. So we're going to cover applications and basic intuition kind of in the slides here. And then we're going to go into kind of hands-on demonstration of how to label your own data. I'm going to cover several different data types and kind of use cases, depending on what you want to do. And then we're going to jump into the code and train a model. And so keep in mind, you can't learn everything in 2 hours. So a lot of this is really crammed in here. But you can totally learn enough to get excited and even start building something useful right away with computer vision. So parts of this maybe or might feel fast-paced or challenging, depending on where you are and kind of what you know about programming or computer vision. That's okay. I think you'll learn a lot by sticking through it. And then the main thing is keep learning after this workshop. And I would suggest to build your own model with all the stuff that we just did. It's kind of designed where I'm going to show you how to do something, and then you can come back to all the resources, and then you have the knowledge of labeling your own data set and solving some other problem. And so it's really cool seeing what people build after the workshop. Just a tiny bit about me. My name is Sage Elliott. I'm a machine learning engineer and developer evangelist at Plainsight. We do really cool stuff around machine learning, computer vision, IoT, across a whole bunch of different industries. And we also create tools to make it easier for everyone to do those things. So today we're going to use the data annotation tool part of it. For about the past decade, I've worked in software and hardware with startups and agencies around Seattle and Central Florida. Really love making things with technology. Feel free to stay connected with me on LinkedIn or Twitter. Twitter, I'm Sage Codes. LinkedIn, you can just search for Sage Elliott, 2 L's and 2 T's, and find me. Now, about you. So normally, if this is an in-person event, I'd love to go around the room and introduce yourself and network with you afterwards. But since the RSVP is pretty high and there's almost 100 people here right now, if you just want to put in the chat where you're watching this from, I'm in Seattle, Washington, USA. And you could also throw in there why you're interested in computer vision. It's really cool seeing where everyone's watching from. So if you want to throw that in the chat real quick, that would be cool. And I miss being connected with people. So we do have a Slack channel. If you want to join this Slack channel, you can. There's an introduction channel there. So if you want to do an introduction, you can do it in that Slack channel. It's also a great place to stay connected with me. After the workshop, a fair amount of people will contact me somewhere kind of asking questions, or if they get stuck on their type of data or training a model. It's a great place to kind of just ask the question in one of the channels, and I'm in there a lot, so I'll probably answer it for you. And then also LinkedIn. So either here or LinkedIn if you want to reach out to me afterwards. Again, I'll share it in the chat again. Setup repeat for anyone who just joined. So again, we'll be using Google Colab. It's an online data science environment where you can do machine learning, really cool stuff. And you just need a Google account and modern web browser. And then again, I'm going to share this link one more time. If you want to sign up for the data annotation tool, you can do so at that link. So what is computer vision? It's a super big field, but I would kind of boil it down to how computers gain understanding from images or videos. And there's other types of data as well that got to be transformed into an image or video. So audio is a big one, right? You've probably seen some sort of visualization of audio. You can use computer vision to gain understanding from that as well. So here's a little example. You can see that this truck is moving. As it's moving, it's being colored green. In this case, that's signifying that it's moving versus these ones that are standing still. They're red. And you can see it's drawing a box around where the truck is, kind of giving an estimate of where the truck is inside the image. And then also it is drawing pretty precisely pixel by pixel exactly where the truck is. So this is called instant segmentation. We'll talk more about the different types in a second, but just kind of, this is a quick little sample. This understands there's a truck, a model's trained on the trucks, and then it's also doing tracking and understanding when something is moving versus standing still. So one reason I love computer vision is just there's so many awesome use cases happening with it today. So here are some use cases maybe you've heard about, and then maybe some fields that maybe you haven't thought about. So everyone has probably used Google or something like that before. There's a lot of computer vision and machine learning happening in a lot of their products like Google Photos, YouTube content filtering, self-driving cars, Waymo's doing really cool stuff, Tesla's self-driving cars, Facebook, you probably uploaded a video or an image and got automatically tagged or suggesting to automatically tag a friend. I see someone mentioned Snapchat filters, which is funny because that is like a big application of computer vision. It's like Instagram and Snapchat filters. That's always kind of a joke where they're like, look what we're going to do with computer vision in 10 years. And then it's like these filters. And then I don't know if anyone's ever heard, this is a pretty small little local Seattle company called Amazon. I don't know if anyone's heard of them, but they do a lot of cool stuff around the world. Obviously, everyone's heard of Amazon, but something you might not have heard of or you might not have gone into yet is Amazon Go. Has anyone been into an Amazon Go store yet? There are several in Seattle, and then I know they're in some other cities. I don't know if they're out of the USA yet. Someone said yes. So it's really interesting. You go to Amazon Go, if you look up, it's just cameras, arrays, and I'm assuming like some sort of GPU processing units, like there's just these boxes up there. And it uses all computer vision to track when you go into a store and what you pick up and assigns those values to you. And then you just kind of walk out of the store. And the first time you do it, it feels like you're stealing. So like they kind of have to encourage you like, yeah, you can just walk out and it will charge you. Really, really cool. And I think it's a really interesting application of computer vision. And I actually used that store a lot during COVID because there's no lines, there's no checkout. You could just go in, kind of grab what you wanted and go to the store. It's kind of cool. They're also doing like delivery robots. There's other companies doing delivery robots as well. And then self-driving cars, they bought a company called Zoox, I think a year ago. And they also use computer vision for like looking at product listings, what's uploaded to Amazon.com. And then here's some other like less common, not just giant big tech companies that maybe you haven't thought about before. And these by no means are all the fields. So there's a ton of them. Agriculture. So we actually do a lot of cool work in agriculture right now. And you can do things like crop monitoring, animal monitoring, construction, right? Site monitoring, like making sure people are wearing the proper safety gear. That's a big thing right now. I know someone, I think they're working on like a self-driving tractor, which sounds really cool. I would love to see that like in a work site, if it can automatically go and like pick something up and move it around. That'd be really interesting. Manufacturing, that's actually how I got into computer vision. I was working at a startup and there was a complicated part that was hard to know if it was good or bad. And I thought I could do this with computer vision. You can measure throughput, supply chain, oil and gas. Again, safety is a big thing, or like detecting leak detections. Anytime there's a site that you're concerned for employee safety or something like that, there's an opportunity usually to put in computer vision or something for some sort of monitoring. And then we talked a lot before we got started with some of the people here about healthcare, things like X-ray diagnostics, MRI scans, a whole bunch going on in medicine research. Does anyone have any fields they're really interested in? Whether it could be one of these, maybe it's one I didn't mention. Again, there's a ton of them. I didn't talk about retail, right? Like retail monitoring, really all over the place. Someone said, is there good progress of pest elimination using computer vision? I've seen some companies working on it. I don't know what the progress level is, but it seems like something that, if it hasn't happened yet, I wouldn't be surprised if that'll happen pretty soon. Like that's a really great idea, right? And I've seen a lot of stuff where, you have these small robots or drones flying around looking at plants and measuring the health. And one of those things could be looking at pests. Someone said they think they would like to work on delivery robots. And it's a really interesting problem, right? Because it's kind of like a self-driving car, but on probably sidewalks. I think most cities, if they have them right now, it's like they have to drive on the sidewalk. And often it's like they come out of a truck or something where it's like a bigger truck will come over and then they deploy all these delivery robots. So they're not driving, hundreds of miles. It's probably like a mile or a couple. But also then you have to account for like people on the sidewalk, and sometimes sidewalks aren't maintained. I think it'd be a really interesting problem. And it would be kind of fun to work on. I've been seeing more and more kind of companies doing stuff like this, like the food delivery companies, right? Kind of researching those. Oh yeah, someone mentioned like Amazon warehouses. That's a big one too, right? Warehouse robotics is huge right now. I think like everyone in the robotics game seems to be getting into warehouse robotics. Even Boston Dynamics recently, because you've probably seen like Spot Mini, the dog robot and stuff like that, or the humanoid ones. They have Atlas, and they recently launched probably a more viable commercial product that is doing warehouse work, which is interesting. Stretch, yeah, I think that was its name, right? Someone said Stretch. Really cool. All right, so computer vision and deep learning. Just want to mention that computer vision isn't always tied to deep learning, but in the past decade or so, pretty much all the things you've seen or applications even we talked about here probably are using deep learning behind the scenes. And that's because it's really, really good at learning really complex patterns. So you could do things like detecting edges or colors without deep learning. But to understand if something's a human in a whole bunch of different variations, probably going to need deep learning for that. So I'm going to just mention that, kind of at a high level of how deep learning works, but I'm going to share some links here that you could go look at afterwards. So just at a very, very high level, this is all you really need to know just to get started and like what we're going to do today and like why you need labels. At a very high level, machine learning or deep learning, you could think of it as you have this model. In this case, it's like an F. You could think of it as a function, either a programming function or a mathematical function. And then we're going to feed it a whole bunch of different training data. And it's going to look at it, in this case, for deep learning, usually looks at a whole bunch of different times. And you'll see when we get to the code, it's like we're going to tell it to look at all these images a certain amount of times and learn features from it. And then once it does that and we think it's a good enough model, then we can give it a new piece of data it's never seen before, and then hopefully return a correct prediction. So let's say we were building a image classifier as an example. This is often something where you'll get started where you build like a cat versus dog image classifier. You would feed this deep learning model, it could be hundreds of images of cats and hundreds of images of dogs, each with the label dog or cat assigned to the image. Like you tell it, this is a cat, this is a dog. And it's going to learn the kind of those features of what make up those animals. And then you'd give it a new piece of data, a new cat or dog it's never seen before, and then hopefully it would return the right prediction of cat or dog. And so the training data is super important. We'll talk about this in a second. The different types of labels that you give to that data is very important. So when you're building something like object detection, instance segmentation, feature points, we'll see examples of those in a second. All those require a different type of label. So it's important to label the data properly with the proper type, and then also just doing it well. So I'll show you some examples of like bad labeling when we get to the hands-on part. And then just a quick note on transfer learning. So most of these popular deep learning frameworks, like the one we're going to use today, pretty much any of the ones you're going to use like PyTorch or TensorFlow, they come with like these predefined models. Like I was talking about how there's so many good ones out there right now. Like you could grab something like called a ResNet that's really good for image classification. And typically these pre-trained models will come with an option of loading in pre-trained weights. So weight is something that happens when you train your deep learning model. It adjusts all these things called weights in the neural network, and then you save those and you can load those back into your data set. And it turns out that if you do that, like if you don't start from zero and you train it on a giant data set, even if the data set doesn't really have the specific object you're going to be trained your new model on, if you don't start from zero, it typically does very well. So you'll see today, we're going to use transfer learning. We're going to be able to feed our neural network just like 300 images, and it's going to train in something like 5-ish minutes or whatever. And the reason why we can do that is because we're using transfer learning. So just think of it as not starting from zero. If you have to start from zero most of the time, it's going to take a lot more images and might take a lot more time. So some types of computer visions applications. I just saw some questions real quick. Let me just catch up on chat real quick. Does anyone have any questions so far? We're going to get into the different types right after this. Someone said TensorFlow versus PyTorch. Really depends on your preference. They're both really good. I've used both. Someone said, are there automatic ways to annotate data used on practice, or should it be manual? I'm glad you asked that question. I'm going to talk about automated ways when we get to the data annotation section. So there's a lot of really cool stuff happening right now of how to automate that, or at least like automate it after a certain point. So you might have to do some labeling and then you can get kind of to the automated side, but it's good to kind of QA your data a lot. Right, so the computer vision field is big, but we're going to focus on kind of like what we talked about, computer vision with deep learning. Many of these types can be like combined together or used with other algorithms to form various outcomes. So we can kind of talk about that as we go. Like someone mentioned, object tracking, right? Like object detection happens first, and then you have another algorithm that can do object tracking. So classification, this is like what I talked about. If we were doing like cat versus dogs, we're going to train a model with just like a whole image of cat or a whole image of dog, give it an image, and then would give us a feedback. So in this case, I trained a model to detect dog breeds, gave this dog, it predicted a Labrador Retriever. And most tutorials will start here and cover kind of classification thoroughly. This gets like, this is great for certain use cases, but it quickly kind of can be a limitation. So if this picture had a cat in the back or another dog breed, right, like the model would probably get pretty confused because it's just looking at the whole image here. It would see this big dog up front, but maybe if there's a Chihuahua, it would throw off the prediction because it doesn't know to count there's two dogs. It only knows one dog, or it would only have like dog or cat or one breed returned here. So you can do it on the whole image or like a specific cropped part, and always like there. And it can be good just to know something's in the image kind of. But a lot of times you want to do something like object detection. So object detection can classify and localize where an object is inside the image. It'll try to give an estimate of precisely where it is. So here, it's drawing a rectangle around. Maybe it's not 100% perfect. You can see there's, several pixels here. So it's not pixel perfect in this case, but it's a really good estimate of where the object is inside the image or video. And it knows there's, more than one. So in this case, there's two geese. It's not just saying goose is here. It's saying there's a goose and I'm pretty sure it's here. There's a goose and I'm pretty sure it's here. So this could give you like the count. That sometimes that's all people want, like how many people are in this space. That was a big thing during COVID, right? Like people trying to monitor, like you can't have too many people in the space together. But also you can localize where they are. So you can see like where the goose is in the frame. Are they overlapping at all? Are they interacting with other objects? There's a lot of stuff you can do as soon as you move over to something like object detection. And we're going to make this today. And we'll cover in depth how to make your data set and train a model, as well as like instance segmentation. I'm going to kind of cover this as we go too, because it's not super different. So I'll show you how to do the segmentation side of things too as well. So like object detection, image segmentation or instance segmentation can classify and localize where an object is in the image, but also can understand more precisely like the pixels assigned to the object. So in this case, we're kind of looking at these water bottles go by. You can see, maybe it might be really small for you, but you can see there is a box around it, just like the truck example. But then more precisely, it's measuring exactly, what pixels belong to the bottle, what pixels belong to the water. And so in this case, you could actually do kind of a volumetric calculation, right? Like how many pixels of water overlap with the pixels of bottle and see when it's full or not. Or maybe it's not even full, just precisely how full the bottle is, right? Another use case, there's so many different use cases for this, right? Like if you really want to be precise on when a object is like interacting with another object, the instance segmentation could be good. Also, just noting, even if you just really needed object detection, like you didn't need the pixel perfect stuff, often the instance segmentation models can be more accurate as well, because they're not just trained on a boundary box around data, they're trained like precisely what belongs to the object. So if you're looking to make a model a bit more accurate, sometimes you want to do instance segmentation as well, even if you don't care exactly about like the pixel interacting with other pixels. You have feature point clustering. So this is big for like, human pose estimation. This is also what's usually used for facial key points. So if you're looking to measure the mood or like facial expressions of someone, you can use feature point clustering. Image captioning, so you can combine kind of CNNs, convolutional neural networks, which is the most common type for computer vision right now, with other types of neural networks, like an RCNN, recurrent neural network, which kind of does like time series stuff. And you can actually do things like kind of train a model on context understanding, like in this case, not just saying like kite, child, beach. It can actually be like, a child is on a beach flying a kite. GANs. GANs are really cool. Something I'm really into is generative adversarial learning. And so I worked on a project, I can share it here, that's kind of cool to read about, of generating original architecture designs. And this post is really good, where you can kind of see some examples of GANs where they can actually, I saw a new one the other day, I think it was from NVIDIA as well. They have some really cool GAN stuff they're working on, and they generated very realistic looking faces. So there's, and not only faces, but whole videos now. So they've been able to do realistic looking faces for a while, but now you can do realistic looking videos that are completely original. So it's like you train a model on all this data, and then it'll create original images kind of based on that data that you gave it. And these images on the side here, that's actually from the project I posted on Michael Hasey's blog. So where we created kind of exterior architecture designs. And before they even looked like buildings at all, it looked like a really cool space art. So something I want to do is get back into creating more stuff with GANs, because the results are always really fun and interesting. One time I did it on cats, and it wasn't that many images of cats, and they looked horrifying. It looked like demon cats that got generated, but it was really fun. So choosing a model. So there can be a lot of different use cases or reasons to choose a model over one or the other, and different ways of tying them together. But when getting started, think about what is the problem you're trying to solve and what is the outcome you're looking for. Do you need the pixel perfect? Do you need the extra accuracy from instance segmentation? Could you get by with just counting and object detection? And there's a lot more to this that's out of the scope of this workshop. Because, sorry, I got a question. Someone said, I can't see any images, only the presentation. Can everyone see? Just want to make sure. Oh, I think they were talking about one of the links I shared. I'd have to go back and look at the link. So sorry. Yeah, maybe they took the images down. So one thing that's out of the scope of this workshop is deploying models. That's a big reason later on about sometimes when you want to choose a model as well. So we'll talk about some object detection models, and some of them are more lightweight and some of them are heavy. So like sometimes you sacrifice like speed and kind of being able to deploy on hardware that's not as powerful versus accuracy. Here's an example, right? This is doing instance segmentation. It can see when this mouse is interacting with this piece of food and classify it as feeding or not feeding. Someone said they want to see the cats. I'll have to dig them up. I think they're on my Twitter somewhere or LinkedIn. I know I shared them there at some point, but I'd have to find them. Object detection in a GIS. So the way we're gonna train a model to do this, we feed it all those images, we label them however we need to label them. What's going to happen is it's going to find proposed regions where it thinks an object is. It's going to run a classifier kind of around there, and then calculate the estimate of the object detection or object location. So this article goes way deeper into object detection. I totally recommend reading it. All right, so some popular object detection methods. We have single shot multi-box detector, or abbreviated as SSD. It does object detection and it does it very fast. So this is a common lighter weight model that people might choose to deploy on like, a Raspberry Pi or a Jetson Nano or something like that. Then you have yellow, you only look once, it does object detection and it's fast. And there's been like several new ones since I've even looked at the benchmark, because new stuff is coming out all the time. So I don't remember where this falls exactly between like SSD and mask RCNN. And unless it's changed, I don't think it was quite as lightweight. So typically, you would still maybe want an SSD for a lightweight thing, but yellow I think is more accurate. And then you have mask RCNN, which can do object detection, instance segmentation, and it has a much higher accuracy, but it can be much slower. And then today, so we're going to actually train something called Facebook Detectron 2. This is what we're going to use today. It's a fork of mask RCNN. And let me just show you an example of what it can do. So you see this little video running, and it'll turn on object detection, just like we talked about, drawing bounding boxes around where things are. And then you'll see this will change over to, I think it's like feature points they use here, just like we showed as well, right? And then this is actually something kind of unique to Detectron 2, which is cool, called dense pose. So it's actually trying to generate kind of a 3D character depending on where the people are. So I've seen some people experimenting with stuff like this for like games, right? Like animating game characters or, you know, people in animated movies, very interesting. And then you have instant segmentation. So again, right, it's drawing pixel by pixel, like estimating where something is and filling it in this case with the color. And then this is, I forget the word for it, penantic segmentation, where it's literally every single pixel of the video is colored in. So you can see it's actually now doing the entire background, and it's classifying as wall tile, wall, microwave, ceiling, cabinet. If you did this outside, it would say like sky or skyline, like a city skyline, depending on what's back there. So this is kind of cool if you need more understanding of like where something is. Is it inside? Is it outside? So this is what we're going to use, and we're going to train this today. And it makes it really like fairly easy to train really awesome models for the object detection and instant segmentation, as well as the feature points. So we won't be going into the feature point stuff today, but you can do that in here as well. So just mentioning real quick, so the full computer vision lifecycle, we're covering data annotation, the labeling side of things, as well as the machine learning, the model selection and training. But there's a lot of stuff to think about if you're actually building something kind of and deploying it in the real world. You have device management. You need to manage your edge computing like resources and sensors. So in this case, like a camera, or again, if you're using like a nano or just some other type of a computer vision box. Data collection, so managing the data from the camera, or creating those data sets. Like sometimes you might use like web scraping, or you might have cameras out in the field take you a whole bunch of pictures and you have to go get the SD card for that and then upload it somewhere. Annotation, machine learning, and then deployment. So running the model on an edge or cloud device, like how do you get this model once it's trained back to that computation device? And then often you want to repeat it for what's called continuous machine learning. And the example I always use for this is, imagine you are building a object detection model for people, and let's say it's like something like the Amazon Go store, some sort of environment where people are coming in, and you want to count for seasonality in this case. So if you trained a model to detect people and it was always in the summer and people are wearing flip-flops and shorts and tank tops and maybe like baseball hats or something, versus people in the winter where they might be wearing big coats, way different hats, giant boots, scarves, your model probably wouldn't be as accurate as at detecting, because the variation would be so different, right? Or if you were detecting geese in grass versus geese in snow or living room or something like that, like changing the back of the environment can have a big impact as well. So typically, if you have something deployed on the field, you kind of want to be continuously collecting and retraining those models, and you avoid what's called model drift. And not going to go too deep or spend much time on it, but we are doing that all in one platform. So we're just going to use the data annotation side today. But if you're interested, or like you have a use case for that, kind of doing all these steps in a unified platform, you can let us know. That's the contact form. And then just recently, we launched on Google Cloud Marketplace. So I'll share that here as well, which is kind of cool. So if you need to deploy this in a private cloud, you can do that as well. All right, so image labeling, we're going to get to the hands-on part. I will pause real quick. I'm going to share this link in the chat. So again, if you want to sign up and follow along, you can do so here. And oops, I minimized the chat. I got to get the chat back up. Sorry, guys. All right, so I shared that in the chat. If you want to sign up, you can do so there. And also, so I'm going to be using several images. If you want to download the exact same images, I'll share the link to that as well. But really, I'm just going to go through several examples. We're not going to label hundreds of images here. I just want to make sure you know how to use the labeler, so when you bring in your data set, you can use all the features. Does anyone have any questions? So while people are signing up, if they didn't yet, let me know any questions in the chat. I might have missed stuff too, so sorry if I missed it. I can't keep up on chat all the time. So if I did miss something and you want to ask it again, go ahead. Oh, someone asked YOLO versus SSD. Again, like I was saying, off the top of my head, I don't remember the current benchmarks for it. My intuition still is that the SSD is lighter weight, but maybe you sacrifice accuracy for it. I think that's still the case, but could be wrong. Oh, someone asked what image folder on the drive. Sorry, so I'm just going to be using the object detection and segmentation one. So not the feature point, not the class one. All right, so I'm going to go ahead and get started to show how I would create a new data set and show you some different things that we can do with it. So I'm going to hit new data set. I'm going to give it a name. So in this case, I'm just going to call it workshop, but you would typically want a more meaningful name, right? Oh yeah, so someone said there's a few images on the drive. Is that enough for our trial? Yeah. Again, you don't need to follow along exactly. I'd even encourage you to try it on, if you just have some images on your computer, bring them in, even if you're just kind of playing around labeling with it. So you can hit save and continue. Now I want to add a source here. I'm going to upload just local files, but we can connect to Amazon S3 buckets and then same with Google Cloud Storage. One cool thing about connecting to the S3 and Google Cloud Storage is there's also a feature of if there's a video in there, you'll be asked how many frames you want to break it down by per second. So if you can import a video and you say, hey, break this down, 1 frame per second versus 30 frames per second or something, so you could label it. I'm going to choose the files here. And these are the examples. Again, I'm not going to spend a crazy amount of time labeling. We're just going to go through and kind of learn all the stuff we need to create our own data sets. So once these are uploaded, or even as they're uploading, I think we can go to the next step here for label annotations or label definitions. So this is where you kind of want to know what kind of model you're going to train, right? Because you need to select the right label. So I'm going to create several different ones here because I'm going to show off doing stuff for instance segmentation as well as object detection, but also kind of some different use cases. So I'm going to make one called Goose. This is going to be the kind of the model we're going to do today, or that we're going to use today. And we have this color here. This is really just for you as the labeler. This is so if I know geese are going to be on a green background, green might not be a good one because it might be hard for me to see. So I'm just going to select blue in this case. I'll hit save right here. You'll see this auto label thing. I'm going to talk about this in a second. Someone asked in the chat, is there a way to automate kind of data annotation? So this is a feature that can help with that. I will get back to this in a minute though, because there's another place in interface you can bring it up. But I'm mentioning that you can set up here. So when you see it in action in a second, if you want to, you could go ahead and set up when you're creating these definitions. I'm going to make another one called Goose Polygon. So I'm going to show the difference between labeling a polygon and a rectangle. And I'm going to make one for car. I'm going to have that be a polygon as well. And I'm going to make one for cup. And then I'll have one for a PCB, which is a printed circuit board. Oops, and let's say I messed up here on this cup one. It should actually be a polygon. So I'm going to go and edit. And I'm going to change polygon and hit save. And do a PCB as polygon. I'll save here. Someone said they couldn't see what I edited. All I did was just change this drop down from a rectangle to the polygon if I went too fast there. All right, and I have one more I wanted to add, which is a PCB damage. So we have like a damaged PCB we could do some labeling on. Someone said they can't see, there's only one screen. So I'm not sure if everyone else can see my screen, right? Someone in the chat said they can't see the screen or something. So I feel like there's only one screen you should be seeing. So I'm not sure if it's cut off for you or what screen you are seeing. But everyone can see the labeling tool, just making sure, right? Okay, I got scared there. I was like, man, that'd be crazy if people were sticking around for so long and they couldn't see anything. I got scared there. Okay, so we made our labels. We have this option of adding instructions. So I'm not going to add any in this case because we're just going to do the labeling ourselves. But this is a really cool feature. If you're doing collaboration with other people, you can invite them into the account and have multiple people label your data. So you want to be pretty specific what to do here. You can also embed examples of like good or bad labeling. And also, right, even if you're the machine learning engineer, often you're not the domain expert. So if someone was having me label X-ray images of tumors or something like that, I wouldn't know what all those look like. So I would want someone to at least provide me some samples that you could get started with looking at that. So you could embed those images here, or if you're going to give this to a labeling team or something like that, you can provide very precise instructions and have good or bad examples. So I'm going to hit save and start labeling. And brings up our labeling tool. Now we have geese. So if I was going to do just object detection, kind of the traditional manual way, I would select my goose label here. And then you want to draw a rectangle around your goose. And you don't want to be too far away, right? Like you want to be as close in as possible. You can hit escape and then edit this label so you could drag it around. So you'd want to do something like this, right? Actually, probably even closer technically. And you could zoom in. We label the other one. And if you want, you can zoom in with your scroll wheel. You can exit out the labeling part, pan around. If you ever really get lost, like for some reason you scroll really far away from your image, you can always hit this resize to fit and it'll bring it back to the default. So this would be the manual way of doing the object detection, and then I would hit submit, right? So let me show you now polygons. So the traditional way of labeling polygons is you have to precisely trace around the object you want to label. Oh, I made this kind of dark. Sorry if you can't see it very well. And I'm going to do a very fast pour job here, right? Like you want to be as precise as possible. It takes a lot longer. So again, this can make a more accurate model and give you the instant segmentation features. But a lot of people sometimes didn't even want to use this because it just takes so long to label, right? Like I'm doing a very bad job here, but you can see how much time that took me to even just kind of trace around this goose versus the rectangle, right? So let me show you a really cool feature. If I go select this label again, goose polygon, I can enable something called Smart Poly. So it's this little button here. I use this all the time, and I can't imagine labeling polygons without it anymore. So you now have this bounding box like we did before, and you want to draw precisely around the goose, just like you're labeling for it. And then you can see that it automatically snapped the polygons to it. So let's do it again here on this goose. Oops. And you can see that it wasn't perfect here. And even my eyes kind of have a hard time telling, like if I zoomed in, like what's the difference between this goose part and the sidewalk. So the tool works pretty well, especially on high contrast stuff, but occasionally, right, like it won't be perfect. But you can click in and then you can just adjust these nodes. So you can click on them. You could also highlight a node and hit backspace or delete and it'll delete it. So if it gets you like 80% of the way there labeling your object, it still is a huge time saver. Right, so you can come in, do that, and then hit submit and be good to go. So let me delete these real quick. We'll come back to a couple other examples of polygons. I'm going to show off AutoLabel real quick. So I'm going to enable AutoLabel back on those rectangles of geese. And this will bring up this interface here. Again, like I was saying, you could set this up at the label definition part. And this currently just has 81 pre-trained classes. But what's coming soon is the feature of like being able to label your own data, create a model from that data, and then tie it back into AutoLabel and then automatically apply labels to your images. So in this case, there isn't a label for goose, but there is one for bird. So I'm going to use this kind of generic bird model and detect the geese in our frames with it. So boom, and then I just hit submit, and I'm going to leave this enabled here so you can disable things by just clicking on it right here. I'll hit submit, and then it goes to the next frame, and it's automatically applying labels. Right. So this, at this point, if this is working good on your data, one of these pre-trained classes, you can really just kind of QA it, right? You want to make sure it's good. If it's a little bit off, you can come in, you could adjust these labels, no problem. So this saves a ton of time because labeling is really, really time consuming. It's usually not super fun, and it takes a lot of time to label like thousands of images. So if you get it to the point where you really just have kind of AI assisted labeling where you're really queuing the data, and it saves an incredible amount of time. And then also, like I was talking about, the auto label feature where not just relying on a pre-trained model, but one that you can train off of, maybe you label 300 images and maybe that gives you a good enough model. Then you can tie it back into this auto label here. And if it's the point where you really trust it, you can just kind of go through very quickly and make sure that it's labeling everything correctly. So let's hit submit here. I'm going to turn off auto label. And then now we're going to do an example with cars. Does anyone have any questions? I'm going to look at the chat real quick. But I'm going to turn on auto label first here with this car. I'll hit auto label. Now I know there's a class for car. There's also one for truck, so I can select that, like if there's anything on the highway that I want to detect, and I'll hit OK. And this is a polygon, not a rectangle. So this works with polygons and rectangles. So it's automatically applied a label to our car. And then these are just like a series of frames. So, right, like now I am just kind of letting it go. I'm like, yep, looks good. If it wasn't, or if it misses it, I'll just add a label in. See, like it missed the car here because if there was a perfect model that would generalize on every single thing, there would be, sorry, I got distracted by the chat. If there was a perfect model that could generalize on every single car, like there wouldn't be a reason to have to do all the labeling, right? So in this case, we didn't train it at cars from cars at this specific angle, so it's not always perfect. So you can come in, I'll use Smart Poly because it's super fast, and then just you want to apply those labels. And I'd hit submit. And in this case, it got this car, but still didn't label these cars. And this would be the great use case of if I could train a model to always look, for cars like at this angle, then it would probably be very good. And then I could just use auto label. And then now it's getting all the cars again. All right, so I'm going to catch up on chat real quick. There's one more cool AI powered feature that we're going to go into, and then we'll get into the code. But does anyone have any questions about labeling so far? So someone said they're still not seeing the screen, but it's the same person. So I'm not sure. I feel like I'm not sure if it's your computer, as long as everyone else seen it, which it seems like they were. Cool. Someone said, can this tool annotate videos or should it do frame per frame? So this does frame per frame. Like I was saying, if you connect to an Amazon S3 bucket with a video, it'll break it down by frames. But if you, so this next feature, so this ties in, I'll just show this real quick and then I'll go more into the chat. So this ties in from frame by frame, like this relies on having a sequence of frames, and this is designed for you to import a video. So we have something called track forward, and I'll enable that. What this does is you can label an object. Again, I'll label it with Smart Poly here. You can label an object in one frame, and this isn't, auto label, like it's not looking for any specific type of class like a cup or anything like the other ones were. This is just knowing that you labeled an object here and here, and I'm going to hit submit. And it's going to go to the next frame, knowing that those objects should probably be in that frame. So it just moves slightly there. I'll hit it again. You can see the angle moves more dramatically, but it's still applying these labels. And this isn't an auto label thing. This is trained to kind of generalize and like do some object tracking based on what you labeled, but not to anything specific. Which is pretty cool. So this is like kind of designed for if you break down a video and you just want to do that sequence, you can. We also have something called copy forward that copies the entire label over. So if track forward isn't working on your data, or you're labeling a stationary object or an object that's not moving much, you can use copy forward and then just drag or adjust the labels when you need to. Yeah, just let's see. Anything else? Someone said, can you repeat how did auto label? Yeah, I could go back into that where to enable auto label. So let's just do it on this cup example real quick. There might not be one for cup, but I would just go hit this little drop down here, click auto label. So all the kind of the features are here except for Smart Polys here because it's used so much. People just want to enable it very quickly. All the other stuff is kind of in this little drop down, and you can hit auto label. And oh, sorry, that was cars. So it already had it one defined. I would hit AutoLabel. I could type in the classes I want here or look through what's in here. I don't know if there's one. I don't think there's one for cup. Oh, there is for cup. I don't know if it will work on this cup, but let's see real quick. Hey, look it did pretty good. So that's how you set it up from this interface. You can also do it in that label definition. There's a part where you can select the classes there as well. Someone said, is it really important to have the polygon really close to the object? Yeah, so if you, again, like, same with the bounding boxes, like you want to be as close to the object as possible. So if I was labeling with polygons and was like just around the cup like this, the model would not do a very good job of like understanding what we precisely want to segment. So it really wants to be like pretty precise. Like, you know, you can have a little bit of wiggle room. And the more you have, maybe the less accurate your model will be. So like if you're doing something as a hobby and it's not 100% perfect, maybe that's okay. But if you really want to like squeeze as much accuracy out of it as possible, you'll want to be like closer than this. Someone said, how many examples of each image thing are usually needed? 10, 100, 1000. So it really depends on your data set. So in this case, right, we're going to train an object detector for geese, and we're going to use, I think it's something like 300 images or 100 something images, but like 300 instances of geese. And it's actually going to do really good on a video that it's never seen before. But the geese, right, like they don't have a ton of variation. So if you're labeling for people or other animals where there's a lot more variation, you probably want a whole bunch more data. So like there is never a magic number of like 100 or 1000. Typically more the better. And for doing something like in the field, you'll probably want thousands of images. Someone said, when they're using this tool, are you sharing the images? I mean, no, I mean, it's in the server, but we're not getting your images. And then there's the version of deploying it in Google Cloud as well, which the Google Cloud one is, that's then your instance. Someone said they are using computer vision to annotate images for computer vision inception. Someone said, do I have an API for Fluently CAPTCHA? I don't. There might be one out there, I'm sure. All right, so let me just do the one example. Let's say we label this correctly. This, if I was just going to do PCB, you know, you could draw like the damage around it, kind of detect these scratches. This is kind of a common one people ask about, so I always just have this as the last example in here. And I'd hit submit. All right, so so now once we've labeled all of our images, we want to export it so then we can use all these in our code. So I'm going to hit export dataset, and then you kind of get these options for all these popular formats. We're going to use Cocoa today. So again, don't worry if you didn't follow along and do the labeling. I'll give you a labeled dataset when we get to the code. One important thing to note right now, I think this is moving soon in the interface, but if you didn't go through and do the approval process, so built in, you could go back to the labeler, you go look at all the submitted images and then manually approve them. So this would be part of like, if you have a labeling team, right? Like you can go back and make sure they did an okay job. You want to hit export data set. If you just trust your own data annotations, you can hit this little box here that's just submitted annotation. So it's not going to be all the approved ones, it's just all the ones we labeled. And then you have this thing called split data set. So you can do train, test, and validate. I'll talk about this when we get to the code, because we will be using the train, test, split. But again, you just have all kind of these other formats here. So Cocoa's one of the most popular ones. This is what I use a lot if we're not using kind of our own generic JSON format. So I hit export now. Once that's exported, you'll get an email with a download link, but also you'll get a push notification here. Sometimes this takes a second to show up. So just for the sake of rushing for the workshop, I'm going to hit refresh. And there's my notification, and I can download my export and that download. So it'll give you a zip file. Inside that folder, you'll see there's an image folder. This is all the images that we labeled. And then you have your train test validation split files. So I'm going to open up our training document. It's going to look crazy, so don't worry. You don't need to know how to read it all. I opened on my other screen. So right, like this looks really crazy. Don't worry, we're going to read this in with a pre-built function. But you can see that like there's something called bbox, that's bounding box. So these are bounding box coordinates. So this is showing where we drew those rectangles at, or where we drew polygons at. So this is just so the model knows where to look at the image and learn from, and then it ties back to these image paths. So you can see the image path goes into that image folder and then references some image there. All right, so that's kind of a summary of labeling. Does anyone have any questions about that? Someone asks, what is the split? So I will get back to that when we get in the code, but typically when you're training a deep learning model, you will want to have a train with the training data, and then as your model's training, you use a validation set to make sure it's kind of going in the direction you want. And then when you feel like your model's good, looking at the validation data set, then you can test it on your holdout test data set. So we're actually going to use all those 3 data sets in a second when we get to the code. Someone asked, they cannot upload an MP4 from local disk. Yeah, so you might have missed it. I mentioned, so you can upload like an MP4 file from Amazon S3 and Google Cloud Storage, but not from local disk yet, but that will be coming soon. Someone asked, are there more classes other than listed in the dropdown? If not, can you create one? So the class, so if you go to label definition, so like the label name, that could be depending on how you like to word things, that could be the class. And then these are all the different label types. So you have like rectangle, polygons, feature points, classification, kind of a generic text one. These are all kind of the main types you'd probably use for most projects. I don't know if there was a specific one you're looking for. So someone had asked that question. Someone asked the numbers of the split. So by default, the numbers are 80% train and 10% test and validation, but you can change that depending on what you need. All right, so let's get set up to do the coding part. Just mentioning real quick some other popular Python libraries. So you probably heard of like PyTorch and TensorFlow. PyTorch is made by Facebook, used for deep learning. TensorFlow is made by Google. They're very similar. They're kind of interchangeable. Like I think even people were asking in the chat, TensorFlow versus PyTorch. People just kind of have their own personal preference. But there could be some things around like deploying that you might specifically want like TensorFlow for, or something that they have TensorFlow.js, so you can actually run the models in the browser, and then TensorFlow Lite, which can become a very lightweight model to go on like mobile devices. PyTorch also has some of those things like mobile deployment as well. OpenCV is an awesome library for image processing and computer vision. NumPy is great at processing multi-dimensional arrays, which is actually what images become when you import them in. And then you have Pillow, which is also an image processing library. All right, so here is the link to Google Colab, and this should also have pretty much all the other links that you'll want. Oh, and I will mention, so we are doing kind of a certificate of completion. So the link to fill out the form for that is at the bottom of this Google Colab. So you can open up this Google Colab, posted the link in the chat. Once you're here, you'll get this Google Colab open, and then you want to go to File and save a copy in Drive. So this will create your very own copy that you can always come back to. And if you really mess it up, you can always come back to this original link and make another copy. So you can hit Save a Copy in Drive. This might take a minute to make your own copy. And someone let me know in the chat when they make their own copy. Someone said done, copy created, awesome. Thank you for letting me know. I don't need everyone to let me know. Just want to make sure that it did work for at least one person. All right, so this is Google Colab. It's essentially Google's way of hosting Jupyter Notebook. Jupyter Notebook is a very popular tool in data science. It allows us to write code, documentation, and output like kind of our visualizations and everything happening all in one place. It's really, really cool, really great for experimentation. Just mentioning, so you don't need to do this right now because by default, because you cloned from me, it is already set to GPU. But one really cool thing about Google Colab is they give you a lot of free GPU time. So a lot of people struggle with hardware getting started in deep learning or computer vision because they don't have a GPU on their computer and usually need one to train models or to run a computer vision model. So I think Google Colab gives you something like 12 hours for free. You can also sign up for Collab Pro, which is like $10 a month, and you get a lot more time. And then it comes pre-installed with a whole bunch of libraries. So it has like TensorFlow and PyTorch already pre-installed that you can kind of just start using right away. All right, and you can double click on this text. It opens up like this markdown mode. To get out of this edit, you can hit Shift Enter. And you can run this code cell here. You can run it by hitting this play button, or when you're highlighted, you can also hit Shift Enter here, and this will run the code. So in this case, it takes a minute to initialize. When you run the first code cell, has to connect and like spin up an instance for you to run everything in, and then you should be good to go. So here we're printing hello world. That's kind of the output function from Python where you can print out text to the terminal, or in this case, the notebook. And you can also run terminal commands. So ls, if you happen to be familiar with like Linux terminal commands, is listing everything in a directory. So you can see right now there's one folder sample data that came pre-installed with Google Colab. Don't worry if you don't know these commands or anything. We only use them a couple times to look at like what's in a folder, but it doesn't really affect anything if you don't know it. So let's go ahead and run these code cells. And I just want to mention that you have to run all these code cells in order. So if you don't, you'll probably get an error. And usually if someone has an error, it's because they accidentally skipped one of the code cells. So this can take a second. And so this is actually one, so depending on how you look at it, it could be a good or a bad thing that Google Colab comes pre-installed with all these libraries. So in this case, everything was relying on PyTorch 1.8 and Torch Vision 0.9, but Colab automatically kind of updates the current version. And so since we had written everything to run on PyTorch 1.8 in this case, we have to uninstall 1.9, which is the current version that they just updated like the other day, and have to reinstall 1.8. So this might take a few minutes. Normally you don't have to do this if you're writing for the current vision in Colab, but it's good to have this as a check so it doesn't break everything, right? Like if you need PyTorch 1.8, you should make sure it's in there. And if not, it will install it for you. Someone said, is there a cheat sheet? I don't have one, but if you look up Google Colab cheat sheet, I'm sure that's out there. We're really just going to use like that Shift Enter to run cells. Someone said, is there debugging on Colab or the notebook stalls at the first error? It'll stall and kind of tell you that there's an error in that code cell. And it returns an error message. Also, if you really want to make sure that you're going to run everything in order, like I'm going to run the code cells as we go and talk about what's happening. But you can also hit runtime and hit run all, and that'll run everything in order. So it'll run one cell. Once it's done, it will go to the next cell. You see this little error here? Don't worry about that because we're not using torch text in this case, but that's just saying that this other library that was pre-installed was relying on that PyTorch 1.8 or 1.9, and we just uninstalled it and did 1.8. So don't worry about any errors today. This should be fine, but eventually I have to come in and update and make sure this all works with 1.9. So we're going to run this. It's going to import Torch and Torch Vision, the libraries we just installed, which Detectron 2, the wrapper, kind of the framework we're going to use today, it's kind of a wrapper around PyTorch. So we're installing PyTorch because it's a dependency for Detectron 2. These are really just to check the versions that are installed because I wanted to make sure they are correct. And then here, this is going to install Detectron 2. So you can see it's looking for this Torch 1.8 version. And this will just take a minute to install. These are really the most intensive parts of installing, and the rest of it should go pretty fast. Is are the code cells working for everyone? Just want to make sure that it seems to be running. I said yes, awesome. All right, so now you can hit Shift Enter on this one. We're going to pip install Pillow, another library. Someone asked, do you think that Keras is good, or at some point should I be switching to TensorFlow or PyTorch? So Keras is a wrapper around TensorFlow, and actually it's used so much now that TensorFlow 2.0 has Keras built in. So to me, I kind of think of them one and the same, because it's kind of just a way of like changing syntax and like writing it in a little bit more friendly way. And pretty much everyone is using Keras, I think, so that's actually built into TensorFlow 2.0 now. Here we're going to import our dependencies. So these are just various things from Detectron 2 and a couple other libraries, like CV2 is OpenCV. We already talked about labeling. All right, so let's go ahead and download this data set. So I'm going to download this and then talk about how you could go about getting your own data set in. So go ahead and run git clone. This has a data set on GitHub. And then I ran the ls command. You can see that we have an image folder and then a test and train and validation JSON, just like we saw when we export our labels. And then you can see inside that image folder is a whole bunch of images, right, with these names, and they're all JPEG. So that's how we're gonna that's how we imported our data set to use today. And don't worry about having to do all this right now, but I'm just gonna show you a couple options of bringing in data sets. So you might not have it always stored on your GitHub or something, and typically you wanna just have a folder locally or a folder on Google Drive to do these experimentations in Collab. So I'm gonna hit this little folder icon here. This brings up this interface. I can actually explore files from here, which is pretty cool. And you'll see you can use this later. So now you could go to your folder where your images are and your data set and actually just click and drag them up into this area. But one thing to note is if you do that, the data in here is not persistent. So that means when you get disconnected or you go away and like exit out of this and come back, that data will be gone. You'd have to re-upload it every time, which probably doesn't work out well if you want to keep coming back to the same data set and you keep wanting to kind of load it into different models. So what you can do is hit this button here, mount to drive. Now, because this is created from my Google Drive, it's not making me do this access code thing, but if you do it on yours, it'll pop up a code cell. It'll kind of walk you through how to mount to your drive and give it permission to do that. But now that I'm mounted to my drive, I can explore my folders and I can actually go into like a data set and find my image folder and find my JSON folders this way. And so what I do here is like I create a folder on my Google Drive for ML stuff or data sets or whatever. And then I would drag or upload those data sets that I exported into my Google Drive. And then I can always just mount to drive here and then connect to them that way. And I'll show you, like, you'll just want to change out these paths to wherever your new data set will live. So let's go ahead and run this code cell. And if I wanted to change this out, so like I would just find where my new JSON file is if it was in Google Drive, and you could just go in, navigate. Let's go back in here. So I'd copy this train JSON, hit copy path like that, and then just paste it in here. And then if I want to update this, which I would need to, so this is for the JSON path, and then this is for the path to the images. This could be one tricky thing that you might make a mistake on. I know I have before is I'd be tempted to hit this copy path from that image folder and put it here. The problem with that is, remember when we looked at our JSON, the path to the images already had that IMG in it. So we want to just leave it like this, and then it'll look at that JSON file and it'll know to go into the image path from this directory. Let's go ahead and run this. This is going to create our train data set, our validation data set, and our test data set. And if you're still confused on that, you'll see how we use it in a few minutes, and hopefully that will clear it up. Let me just see. I think there's a couple of questions. Chat. Someone said, do you have a link to the labeled data set? I missed it. Oh yeah. So if you didn't get the link to the Collab notebook, it's already in there. You just need to run the code cells. And this is designed so like you can run these code cells. We're going to talk about what's happening, and then you should come back and replace things with your own data set or your own variables, and then you'll be able to create your own kind of project. And so here you have my data set train. Let me just go ahead and run this. Essentially what this is doing is just saying for data in random sample, like get 3 images and read those in using OpenCV. Remember, CV2 is OpenCV. And then we're going to use something called visualizer from Detectron2, which is drawing out these visualizations. You'll see this weird annotation happen sometimes with images. And the reason for that is this is essentially flipping the RGB values. And OpenCV reads images in as blue, green, red, so BGR versus RGB, like most other things. So you actually want to swap those around. And that's just what this is doing. It's just kind of rearranging the array in Python. And then we're writing out our image here. So you can actually see that these are just reading our data set and visualizing it out. So the reason you want to do that, right, we labeled our data set. We want to make sure that we read it in properly with our code. In this case, we're building or using a pre-built function called register Cocoa instance from Detectron2. And it's probably fairly reliable, but there's actually been a lot of cases where I wrote my own custom data loader or something, and I thought I did it right. And then when I read the images in, I messed up something and the rectangles were not in the right place. So you always want to make sure that your data is being read in pretty correctly. And here you can print out that dataset dictionary variable that we made. And this is just like our JSON like we saw before. This just has kind of the annotations, like where those bounding boxes are for object detection. And they link back to each image. So this is where we're going to feed our model. So I'm going to run this code cell, and I'm going to go ahead and run this code cell under because it takes a little bit to run. This is where we actually do the training. I'm going to come back and talk about what these code cells are doing, but I just want to get a head start because this takes a few minutes to run. So this part, I guess I can link this in the chat. I know that you also have these links if you're in the notebook. One thing about Detectron2 that's kind of annoying is by default, it doesn't have a good way of running the model on a validation data set as it's training. So I've linked to the Medium post where this is from, but essentially this is creating your own class where as you're running a model, the model will learn from the training data set, and then you want to run that current state of the model on a data set it's never seen before and see how well it does. So first it's going to do very awful, and then if your model is training correctly, it should get better over time, because it'll almost always get better over time on the training data set because it's seeing it and actually learning from that data set. But you want to make sure that it's going to generalize pretty well on data it's never seen, and that's where the validation data set comes in. So as you're training, we'll see that every 50 cycles of learning from our training data set, we're going to run the model on a separate data set it's never seen and see how well it does. And so we would expect it to be very awful at first and then get better over time. And then just noting Detectron2, so you can read the docs here and go deeper into everything. And then also they have something called a model zoo. So we're using an object detection model today. That's what this URL is. You can find all the other models in their model zoo. So they have things like instant segmentation. So actually link to that up here. And I'll talk about swapping that out in a second, but they have other models as well, like the feature point detection. So here we're going to set up our model for training. This is kind of the convention in Detectron2, create a variable. We're calling it a CFG config. That's kind of how they do in the documentation here. Say get config. And then once we have this variable, we're saying merge from file, and then we're passing in this model zoo URL. And so like I was saying, you could find other models on there if you want, but we're going to use a Cocoa detection one. And you can see it's a faster RCNN. If you wanted to do a instant segmentation, you could actually copy this one I have saved up here and just swap out this URL. But it's very important to note, if you're swapping out that URL, you need to swap out this URL as well. They need to be matching. This URL says config model weights, and we're pointing it to the model zoo again to the same URL. And remember when I talked about transfer learning, how pre-trained or frameworks usually have these pre-trained weights that you can use. That's what's happening here. So we're taking this Cocoa detection model, we're loading in the pre-trained weights from, I think it's the Cocoa data set, And so we're not starting from zero. We're going to pass it in our new images, and it'll not start from zero, and you'll see it'll actually train pretty quickly in this case. So someone said the model is loaded, pre-trained on Cocoa, and fine-tuning on our data set. That's correct, yeah. So often called fine-tuning, where you load in a pre-trained model and then you pass it new data. In this case, this is an important parameter to run or potentially to change. So this is how many classes are in your data set. In this case, we just have one because it's just geese, or a goose that it's going to find. But if you did goose and duck, you would change this to 2. Goose, duck, and boat, that would be 3, so on. So important to change this, otherwise your model won't work well on all of your data. This is our data set that we're learning from, so our training data set. This is our max iteration, or the number of epochs that we want to kind of go through our data. So it's 300. We're going to look at our data set 300 times and learn from it. You might want to adjust this, way more depending on how much variation is in your data. Learning rate, we won't really dive into learning rate, but it's kind of something that affects how your model learns. So it's another hyperparameter you can adjust. And then same with these other things, we don't need to go into them today, but you have the option of like adjusting number of workers. So you can use different number of GPUs and stuff like that. And then this is creating our directory for our output, which we'll see in a second. And then this is where we say, use my dataset validation, and every 50 cycles, run our model on that validation data set and give me the output. So we'll look at this output in a second. I know we didn't really get to see any of it yet, but that's what's happening down there. And then essentially we're just having it train. So let's go look at our output. When it starts out, this is actually kind of what the convolutional neural network looks like. It looks kind of crazy in this area, but this is how I think it's the ResNet 50 is structured. Then you can see that we loaded in 110 images for our training data set. There's 260 instances. So most of those images have more than one goose in them. And there's only one category, which in this case was goose. Don't worry about this warning. So this is when you change the output layer. Remember, the Cocoa data set has like 81 classes, and then we changed it now to 1. So it's saying like, hey, this doesn't fit, but don't worry about that error. Then you can see our validation data set is 37. So now as we're training, you'll get some kind of stuff, some data here. And then this is what I like looking at in this case is the metrics from the validation data set. So you can see this AP, or average precision. I have a link in a second that goes way more into these metrics. So don't worry, like average precision and different ways of measuring accuracy of object detection can be a little interesting, because it's not just like classification where you could say, yes, this is correct, or no, it wasn't correct. You have to measure if, how close were the predicted rectangles around the object? Like was it exactly as it was labeled? Was it way bigger? Was it shifted over? So there's kind of ways of tracking that. And again, I'll have a link that goes way deeper into it about these different metrics for object detection. But essentially, the higher the number, the better. So we can see right now, this first one is 32, which might be pretty low. And then, after 50 cycles, now it's 67. And then now it's 81. And then it should keep going up, or you might kind of plateau at some point, right? Like now it says 79 here. Was there anything else missing? Oh, so the other output from the training data set, so you can see things like total loss, which is something you want to look at often when you are also training deep learning models, and some other metrics. Again, I'll have links to learn more about these if you haven't trained a deep learning model before. And then, so let's run this other cell. Occasionally people say that this doesn't run. So if it doesn't, don't worry, it doesn't ruin the rest of the workshop. But this is called TensorBoard. So it's a good way of, let's see if it will load for me. It's a great way of visualizing your kind of training output. I'll show what I mean in a second. So here, again, we'll talk, or I'll give the link about AP, or average precision, in a little bit. But like in general, if we want to know it's going up, we can look at this data and see, cool, it's going up, it's going up, it's going up. Looks like it's starting to plateau a little bit, but this still might go up a little bit more if we had trained more. So maybe we would want to increase the amount of training cycles and hope that this would continue to go up. You can also dive into other metrics, like if you want to look at, the loss and other fast RCNN metrics, you can kind of just see how everything did in here during training. So you can see these numbers are like the number of epochs. So at 300, this is where this number was at. It started at 0 and then it went up. So in this case, it's accuracy. That's a good sign. If it kind of just dropped or like didn't really go anywhere, then we did something bad and our model never trained correctly. So let me move on here. I see there's I think a couple questions. I'm gonna go through some of this part pretty fast, and then I'll make sure I can kind of go back through these questions. So if I run this, this is just looking at our output, but we can also see that like in this folder here, again, if you didn't have it open, click this little folder icon, I'm gonna output, and you can see that we have a model final PTH. That's kind of a PyTorch extension for the model. So this is actually what we want to load in and now use it to run on images or video. So let's set up our model to run it on images, or we're going to do it on images and then a video and like draw those outputs out. So kind of like we set up for training, we have this like CFG, get config, and then we're saying what type of model it is. So this again should be the same one as you trained. If this isn't the same as the model you selected during training, it'll throw an error or just won't read in the data correctly. So if you do the instance segmentation, then you would want to change this out to be instance segmentation as well. And then instead of passing in the pre-trained weights from like we did before from the model zoo, now we're loading in our weights. So this would be the path of wherever your PyTorch model is. So this is already correct. You don't have to do this, but if it was in a different folder or you saved it somewhere in Google Drive and you want to come back to it, you can navigate to it, hit copy path, and then paste it here. And then we're setting up a dataset test. We'll run one other test metric. So we looked at our validation. The point of like the validation is like, as I'm training, I can adjust things like hyperparameters to make sure that it's working good on that validation data set. So the validation data set, I kind of like to think of it almost as another training set before the human, potentially like the human in the loop here. So if I'm adjusting things like adding more data or adjusting learning rate or anything like that, I can see how well it's doing on the validation data set, but then I want to save my third test data set till I feel confident my model's good. And then I can see how it really works on data that the model's never seen and that I've never seen how it runs on it. Then we have our number of classes. So again, if you change this on training, you would change it here. Again, it's just 1 for goose, but if it was goose and duck, it would be 2. And then this is saying don't count it as a prediction unless you're this confident. So right now we're leaving at 9 or 0.9. So this is saying if you're 90% sure it's a goose, draw it out as a goose or count it as a detection. But sometimes your models may not be as accurate. So you might want to bump this down to like 60% or 80% or whatever it is. So if you train a model on your own data set and you're not getting any outputs after we do this, try lowering this because your model just might not be as confident or have high of a score. Then we make a predictor variable that we can use to pass in our data and get predictions. So here I'm going to go ahead and run this. We're reading in a image from our test data set. And we're reading it with CV2. And then we're creating an outputs variable. So we're passing in our image to our predictor function. That's going to return some data that we'll look at what that looks like in a second. And then we're using the visualizer from Detectron2 and just kind of scaling the image down a little bit and then drawing it out with OpenCV. And so you can see that we got a box here and it says 0. So it's a class 0. If we had a class 0 or 1 or 2, those would all be drawn out. If it was a goose and a duck, the duck might be class 1 and the goose would be class 0. So Python, like most programming languages, indexes at 0. So you can think of that as kind of 1. And it's pretty highly confident this is a goose, 98%. And this says 100 is probably rounded up. So did anyone else get to this point so far? Were you able to train a model and run it on an image? I see people say yes. Awesome. Congratulations, especially if that was your first deep learning model or computer vision model. It's a lot to go through, seeing all the labeling process and then doing the training and then running it on an image. So give yourself a round of applause because it's super cool. Like you've trained a state-of-the-art model that it's really good in this case at detecting geese in parks. And you can swap out those variables like the data sets and train your own model now to do object detection on it, which is awesome. So real quick, let's do some more examples and then we'll run this on a video. So if I print out the image, remember I talked about NumPy is really good at multi-dimensional array stuff. And this is what an image actually looks like inside of Python right now. So here we have three variables in a multi-dimensional array, and these are actually the red, green, blue numbers here. Just wanted to show that real quick. And then this is what the output looks like. So when we are running, or when we pass this image into our model, this is actually what's getting returned. And those visualizations are really great to look at because we as humans love looking at these visualizations like rectangles and stuff like that drawn around objects. But what's actually maybe more important here is what's coming out of here. And this is how those rectangles get drawn, but we don't always need to actually draw them out if we're making decisions afterwards, right? Like if we are seeing if the bounding boxes are overlapping, we could just see like, are these pixel values overlapping with each other? These are the coordinates for the rectangles. Or if we want to see just count how many geese are in there, right? And just return that value, we get this number of instances. Or just seeing the confidence of, you know, how many, like what were the confidence of detecting a goose? So in this case, 99.58 and 97.61. So this is the really important data where you can have kind of another abstraction or an algorithm or something like that, do something with this data. And maybe you don't always want to write out the visualizations, even though they're awesome to look at and super useful to see as a human. Right, so let's do another example. Oh, this one is just showing like, maybe it is you just want to see there's 2 geese in the frames, right? Again, an example that you see a lot of people doing is something like that during COVID, how many people are in a room or in an area. So you could do something like this, and maybe that's exactly what you need to do to solve your problem. Let's do it on another image here. Just one more example. You can see that there's some photoshopped geese in my living room, and it's also detecting them, which is great. All right, so evaluation metrics. I talked about how you could read way more into this. These are some great places to look more into evaluation metrics. Someone said, you have beautiful, beautiful pet geese. I wish I had geese. I wish I could actually have them in my apartment. That'd be really fun. Maybe not, I don't know. They could get pretty loud. So here, we're using a pre-built evaluation function from Detectron2 called Cocoa Evaluator, passing in our test data set. And then this will return kind of the same things we were looking at before. Again, you can read way more about the evaluation and like what's actually happening, what's good to look for. But again, if we just want to look at this kind of average precision or mean average precision score and see how good it's doing. So in this case, it seems like pretty good number, probably almost 80%. And the most we could go is like 100. All right, so one more thing in terms of code is we're going to run our detections on a video. So it's really cool seeing your model on an image, but it's even cooler seeing it on a sequence of images or a video, right? And it's a really cool thing to share as well. Like if you create a model on your own data set and then you run it on a video and it's doing really cool detections, it's awesome to see. And I love to see it. So if you do that, like definitely tag me or share it with me somewhere. It's really cool to see what people build after this workshop. So here, I'm going to import this, or this is actually just displaying this video here. It's not doing anything to it. This is just a little video of geese that I took. And let's go ahead and run these code cells. We're just going to pip install something called YouTube DL, YouTube download, so we can download my goose video from YouTube. I'm going to download this video. And it should just take a second, hopefully. Seems to be going a little slower today. Of course, during a live demo, that's the time when everything likes to slow down. This next code cell, we actually don't need to run it right now. But I left it in here because sometimes you want to do like run the model on a smaller clip of the video. So in this case, our video is not very long already, but if we had maybe a 30-second video and we want to make sure that the model is going to function the way we want it or the way we think it should on that video, we could create a small video clip of like 6 seconds, 3 seconds. You can change this value here and then just run the model on the video clip. So we're not going to do that here. We're going to run it on the full video once it's downloaded. But I just wanted to leave this in because I found this super useful sometimes to do like, I'm going to do a 3-second clip instead of 20 seconds or something. So here I'm going to run this code cell and talk about what's going on as it's running because it'll take a little bit to run. And then I'm going to go ahead and just run the code cell afterwards. It won't do anything until this one is finished. So you can see the progress bar is going. This means it's running the model on our video. So what's happening here is we are getting a lot of info from our videos, just like what is the frame rate, what is the width and the height, so that then when we output it with the visualizations, we can match this or not. And then we're using the OpenCV video writer function. We're going to call the file that we save out.mp4. You have some other kind of parameters here, like do you want frames per second to match or not? Like that's what we're doing here. We're getting the frame per second and then we're matching it, but you could adjust this if you wanted. Same with width and height. And then we're using the video visualizer from Detectron 2, kind of getting some data. So like the classes from the data set essentially. So it'll write out goose. It won't just say like 0 or nothing at all. So if you have multiple classes, it won't just draw boxes. It'll say like goose or whatever they are and draw the boxes. And then this function essentially is just, while there's frames left in the video, take that frame, like take the current frame, run the predictor just like we did on the individual images, except for now we are passing that visualization out of the loop, which is going to go into the video writer from OpenCV. So it's just going to run the visualization just like we saw in those images and then kind of pass it through and then stitch them together and create a video. So the video is just being broken down for frames and we're saying, well, there's still a frame that we didn't look at yet, run the visualization and then write it out to a video. And then that's done here. And this can take a minute to download as well. Last time I did the workshop, it took like a weird amount of time. So hopefully it's going to go fairly fast today. It's going. Is anyone else at this point as well? Are you almost downloaded or maybe you even got your model downloaded? Also, so just to mention while that's happening, so this is the form link for the certification. Like I talked about, we're doing now something like a kind of certificate of completion of this workshop, which is something people had asked about. So I thought we should do it. And the new one might look a little bit different than this. So don't be surprised if it looks hopefully cooler than this one. And it might take me a little bit to get back to you as well. Okay, someone else said they're downloading the MP4. The suspense is here. Oh, someone said they already downloaded and played. Did the model work for you? People are saying yes, awesome, looks good. Can't wait to show it. I don't know why everyone else is going faster than mine. Man, is mine frozen? Oh, there it's going, Awesome. So if you got it done, again, congratulations. Like you went through, saw how to label a data set, train a state-of-the-art model, and then run that model on images and run it on videos. So someone said, so if I try this with the same code with my own images, will it work? It should, as long as you do the proper labeling, and then you want to adjust the part of importing the data set with your own data, right? So if you watched, I don't remember if hopefully you saw the part about labeling and exporting. And once you export those labels, you can bring them into the code here and it should work, yeah. So hurrah, we have our goose detector going on and it's doing a great job. And so I'm going to stop the recording here, but I will be hanging out and answering questions. And if there's anything else, I know I probably missed some questions as well. So I'm going to stop the recording here. Again, congratulations if you made it this far. There's some extra resources down in this Collab notebook. So if you're watching the recording, there should be a link to the Collab notebook below as well.